Welcome! In this video, we will explore the power of Python's built-in modules, also known as the standard library. These are pre-installed modules that come with Python, ready for you to use in your projects. We will cover three commonly used modules: the math module for mathematical operations, the random module for generating random numbers, and the datetime module for working with dates and times. Let's dive in. Let's understand what built-in modules are. These modules come pre-installed with Python, meaning they are readily available for you to use without needing any additional installations. You can simply import them into your code and start using their functions and classes immediately. Since it is a part of Python's batteries included philosophy, it provides a wide range of tools out of the box. Now let's see how to import these modules. Here's the basic import syntax. You use the import keyword followed by the module name. If you only need specific functions from a module, you can import them directly using the from keyword, followed by the module name, then import, and then the function name. You can also import a module with an alias, which is a shorter name you can use to refer to the module in your code. This is done using the import keyword, followed by the module name, then as, and then the desired alias. The math module provides access to a wide array of mathematical functions and constants. Some common constants include math.pi, which gives you the value of pi, math.y, which gives you Euler's number, math.inf, representing positive infinity, and math.tau, which is 2 times pi. Let's look at an example of how to use these. First, you import the math module. To calculate the area of a circle, you can use math.pi multiplied by the radius squared. To find the square root of a number, you can use the math.sqrt function, and to calculate the power of a number, you can use the math.pow function. The math module also offers advanced functions for trigonometry and rounding. Trigonometric functions like math.sin, math.cos, and math.tan are available for calculating sine, cosine, and tangent. You can convert between degrees and radians using math.degrees and math.radians. For rounding, math.ceil rounds a number up to the nearest integer, math.floor rounds down, and math.trunc truncates the decimal part, removing it entirely. Here's how to use these functions. After importing the math module, you can convert an angle from degrees to radians using math.radians, and then calculate the sine of that angle using math.sin. For rounding, you can use math.ceil to round a value up, math.floor to round down, and math.trunc to truncate the decimal part. The random module is used for generating random numbers and making random selections. Some common functions include random, which returns a floating point number between 0.0 and 1.0, randant, which returns a random integer between two specified values, choice, which selects a random item from a sequence, shuffle, which shuffles the elements of a sequence in place, and sample, which returns a list of unique random elements from a sequence. To use these functions, first import the random module. To generate a random number, you can use random.random for a float between 0.0 and 1.0, or random.randant for an integer within a specified range. For random selection, you can use random.choice to pick a random item from a list, and random.shuffle to shuffle the list itself. The random module also includes advanced features for generating numbers from statistical distributions. The random.gauss function generates numbers from a Gaussian, also known as normal distribution, given a mean, represented as mu, and standard deviation, represented as sigma. The random.uniform function generates numbers from a uniform distribution between two specified values, represented as a and b. Also, the random.seed function initializes the random number generator, allowing you to reproduce the same sequence of random numbers each time your program runs, given a specific seed value, represented as a. Here's an example. After importing the random module, you can set a seed value using random.seed. This ensures that the sequence of random numbers generated will be the same every time you run the code with the same seed. You can then generate numbers from a normal distribution using random.gauss, specifying the mean and standard deviation, or from a uniform distribution using random.uniform, specifying the range. The Datetime module provides classes for working with dates and times. The key classes include datetime.date, which represents a date without the time, including the year, month, and day, datetime.time, which represents a time independent of the day, including the hour, minute, and second, datetime.datetime, which is a combination of both date and time, and datetime.timedelta, which represents a duration, expressing the difference between two dates or times. Here's an example of how to use these classes. After importing the necessary classes from the Datetime module, you can get the current date and time using datetime.now. To create a specific datetime object, you can pass the year, month, day, hour, minute, and second as arguments to the datetime constructor. To calculate the time difference between two datetime objects, you can subtract one from the other, resulting in a time delta object. The Datetime module allows you to format dates and times into strings and parse strings into datetime objects. Some common format directives include %y for the year with century, %m for the month as a number, %d for the day of the month, %h for the hour in 24-hour format, %m for the minute, %s for the second, and % for the weekday name. Here's an example of how to use these directives. After importing the necessary classes from the Datetime module, you can format a datetime object into a string using the trove method, passing a format string that includes the desired directives. You can also parse a string into a datetime object using the trove method, passing the string and the format string that matches the string's format. Python has many other useful built-in modules. The Statistics module provides mathematical statistics functions such as mean, median, and mode for calculating averages, as well as dev and variance for measuring the spread of data. The Collections module offers specialized container data types like counter, for counting hashable objects, defaultIct, for dictionaries with default values, and deque for double-ended queues. The module is for regular expression operations, enabling pattern matching, text extraction, and string substitution. The itertools module provides functions for efficient iteration, including infinite iterators like count and cycle, combinatoric generators, and sequence manipulation tools. The OS module is an operating system interface, allowing you to perform file and directory operations, access environment variables, and manage processes. Lastly, the JSON module is for encoding and decoding JSON data, with functions like dumps for encoding to a JSON string and loads for decoding from a JSON string, as well as file reading and writing functions. When working with modules, there are several best practices to keep in mind. Import only what you need to keep your code clean and efficient. Use aliases for long module names to make your code more readable. Group your imports at the top of your file for clarity. Separate standard library imports from third-party imports to distinguish between them. And avoid wildcard imports such as from ximport*, as they can clutter your namespace and make it harder to understand where functions and variables come from. As you can see in the example, standard library imports are grouped together. The good practice is to import exactly what is needed. Avoid importing everything from a module using the asterisk symbol. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.